Good afternoon. Thank you for being here. My name is Danilo, and I'm technical evangelist in Amazon Web Services. If you have any questions that I'm not able to answer here today, you can find me on Twitter as Danilop, and Danilop is also my GitHub account.
And I'm Sebastien Stormacq. I'm also working for Amazon, not for Amazon Web Services anymore. I'm working for Amazon Alexa. I'm solution architect. I'm helping customers to develop Alexa skills. And as my accent and your accent doesn't make it obvious, we are both based in London, in UK.
Okay. So as you may have realized, there was a change in the agenda. So the speaker that was supposed to speak at this time slot, he had to go to the doctor. So unfortunately for you, there's the two of us speaking. And what better topic after lunch than machine learning? So the idea today is to give you, this is really a session for developers, to give you an idea of how machine learning works, what is the terminology, and then we will together build a model using some public data sets, and then we will move on to add predictive capabilities to your app,
and we will finish to show you how to integrate machine learning and how to integrate prediction with a voice-based interface, how you can talk to a machine learning system, how you can talk and ask prediction to a machine learning system using Alexa and the Echo devices.
I personally love this picture. Anybody here in the audience knows what these people is doing? These people are counting tickets from the London Underground. This is March 1939, and they were counting something about 4 million tickets to understand how the Underground was used and to plan for the next extensions of the Underground. So when I see these heroic efforts, I think that today we really have no excuse to use data to improve our life, to improve the way we work and the way we live at home. What we see is that our customer starts with an approach that is similar to the one that we saw previously, but of course everything is automatic. So they start analyzing data in batch. So maybe they build a daily report, a monthly report, a weekly report, and in this way you can look at what's happening in your business, in your town, but you look at the past. The second step is usually to start looking at what is happening right now. Introducing real-time monitoring to your platform so that you can receive immediately alerts if something is not going as you were planning. And the third step is looking to the future. So use the data that you have to build a model and create predictions. Actually, predictions is probably the main topic that we will move around during this session. And to build prediction, you need data. You need some data that it's the leverage on top of which you can understand how things are working and extract some pattern. And to do that, you build a model. So the model is the way to abstract the behavior of data in a more general approach so that you can create predictions. And how can we build models? So this is really one of the most promising fields of these years. It's not a new field. It's part of the artificial intelligence umbrella. And machine learning is the capacity to let machine learn. And the idea is to extract patterns from data, to find patterns in data so that the machine can understand not just the numbers, but the behavior of the numbers, for example. And machine learning is probably going to really change the way we are living in the next 10, 20 years. There's people suggesting that probably machine learning will have an impact on our society comparable to the Industrial Revolution a couple of centuries ago. So when we talk about machine learning, there are two ways that you can learn from data. The two main ways are using supervised learning and unsupervised learning. With supervised learning, what we mean is that you have data that is labeled. By labeled, I mean that you have all the information on what happened in the past, including the variable that you want to predict. Unsupervised learning is a more general approach when you want to infer a model from data that is completely unlabeled. So, for example, you have 1,000 or 1 million customers in your company, and you want to understand if this customer has something that links them together. There's another category that sometimes it's considered apart from supervised and unsupervised learning. It's called reinforced learning. And it's similar to the way that we learn. So the idea is that you don't have our brain don't learn like in a period of time, and then we stop learning and we only apply what we learn. We continuously reinforce what we learn using the feedback that we receive from our senses. So reinforced learning is really useful when you have a dynamic environment, such as for self-driving cars, or even for games. So if you want to teach a machine to play chess, you can use reinforced learning, so the machine can start playing at random, and based on the feedback, it can improve and learn how to behave better. So these are probably two of the most common examples. For unsupervised learning, the idea of clustering is really the most common example. As I said before, consider a company. Usually you have lots of customers. You can't know each customer in detail. So you want to usually create clusters of customers, understand maybe the new customers, customers that use some products in a different way, plus customers that are at risk of leaving your company, going to use services from another company. What you need to do is similar to what you see visually in this slide. So you have points, and these points are like a visual representation of the different variables that you know from your customers, like how much they spend, how much they could spend, how many tickets they open on your customer support. And you want to find the best way to group these points together. So probably visually here, using just our eyes, we can say that probably 3 cluster is the best setup. But this is really easy because we are working only in 2 dimensions. Think of this with tens, hundreds, or thousands of dimensions, and of course you need a machine to really do proper clustering. With supervised learning, so when you have labeled data, usually those are the 3 targets that you want to reach. So one is to do regression, so you want to predict a numeric variable, like you want to predict the traffic in a town. So probably if you want to predict the traffic in a town, you want to predict the average speed in different streets in kilometers per hour or meters per second. So it's a number, usually for the machine is a floating point number, then maybe you can round up to an integer if you want to predict something that is an integer. And then there is classification. Binary classification is classification among 2 different classes. The very common one that you probably use almost every day is email spamming. So you receive emails and you want to classify this email as spam or not spam. Another extension of that is that when you have more than 2 classes, so multi-class classification, for example, you can classify movies by genre, and you can have comedies, thrillers, historical movies, and so on. So you have multiple classes. When you start working and playing with machine learning, a very, very important aspect of your experience is validation. Because it's very easy to create very complex models, very complex procedures, but if you don't have a way to validate your model, then you really don't know if everything that you did makes sense at all. The best way to do validation is to take all your data, so that this is the data from the past, and split the data into different sets. One set, you use it for training, for creating the model. The second set, you always keep it aside from the training of the model so that it never touches the model. And when the model is ready, you apply the model on the validation set, and you can really see if the model is capable of abstracting what it has learned on the training set on a different set of data. It's very important that you don't use the same data for training and for validation. Otherwise, it's easy to get a biased model that works only on those data and doesn't work when it gets real-world data. Usually, training a model means that you have some sort of error function that defines how far you are from your predictions to the value that you want to reach. And this becomes a mathematical problem, so you want an optimization problem. You want to minimize the error function that you define on top of all the parameters of your model. One issue that it's quite common with machine learning models is overfitting. So, for example, let's look at these points here. Maybe they predict the speed on a street over time. So on the x-axis, we have time. On the y-axis, we have the average speed of cars. And we can say, OK, I want to use my most complex model to understand and predict how the speed works. And you can end up with this very perfect fitting. This is a curve that goes exactly across all the points that is in your data set, that are in your data set, and it's fitting perfectly. And if you use this curve to predict new data, you get these predictions. So you probably say, OK, if I go back in time before my first point, probably the speed was faster. If I go in the future, the speed will be almost the same of my last point. Actually, data from the real world is always dirty. You never get clean data. So this is a much better fitting for that values. So a simpler model usually gives you a much better prediction. And the prediction, as you can see, are completely different from those that you were getting from an overfitted function. So this is another risk. And one way to reduce this risk is to use, of course, validation. So because validation is using data that is outside from the training data, you can check if there was overfitting. Usually, the same model doesn't work on different data. Another way is to use regularization. The idea is to add to your error function some sort of a cost that grows together with the size of your parameters. So the more parameters, then the bigger the parameters are in your model, this cost grows. And there are two ways of using regularization. One is called L1. That means that you use the absolute value of the sum of the sum of the absolute values of the parameters, and then you have some sort of variable to reduce this when you use it together with your error function. L2 means that you use the squares. Usually L2 is the most common one and works very well. So most machine learning pre-configured platforms use L2 regularization to avoid overfitting on top of the validation. So now we have the data that we get from the test. We want to get a model. We need some tool to create this. One tool that is very common recently for machine learning is Apache Spark that you can, for example, run on AWS using our Elastic MapReduce platform. Because Apache Spark has a very powerful library. It's called mlib. It's an open source library that you can use and includes a lot of machine learning models that you can use and fit and validate. And it also works in memory. So Apache Spark, compared to the older MapReduce approach, is working in memory. So data is working in memory, and this is usually much faster for machine learning algorithms that usually work and iterate on the same data again and again. Of course, if you use a platform like Apache Spark, you need to really know what you're doing. So you need to choose the algorithm, you need to split the data into validation, training, test different parameters. So you need some skill. And in Amazon, we found that you need a data scientist if you really want to work on machine learning at this level. The problem is that for us, it was impossible to have a data scientist in all of our project teams. Usually, data scientists are quite a precious resource, and you want to use them, deploy them only when you really need them. And so the idea was, how can we overcome this limit in Amazon? We use machine learning a lot for recommendation, for predictions. The idea was, let's create a platform internally that is easy to use for developers that need to know only how this works. They don't need to be data scientists. And then this platform can be provided via API to all the developers inside Amazon to add some smartness to their applications. And that's how Amazon machine learning started internally to Amazon. We used it for a few years, and then 1 year and a half ago, 2 years, we made it available for everybody to use as part of Amazon Web Services. And with Amazon machine learning, you can build models that can create batch predictions. So you can have a set of data to predict, and you get all the predictions. Or, and this is what we will use in the demo afterwards, you can do real-time predictions. So when you have your model up and running, you can query the model and get predictions in almost real time, in the matter of milliseconds. those are the kind of optimization techniques that we support in Amazon Machine Learning. So those are the three of supervised learning that we saw. So regression, binary classification, and multi-class classification. There are some details here. I'm not really entering into details, but for people coming from a mathematical background, they know that gradient descent is one way to find the minimum of a function. So the idea is to use gradient descent to find the minimum of the error function. The idea of using stochastic gradient descent means that since you have possibly hundreds or thousands of variables, it's impossible to really solve analytically the problem. So you iterate on different variables using the gradient on different variables one at a time. So let's start with the first demo. We will have quite a few demos during this session to see how we can create a machine learning platform. And then we will use the same model that we create in the demo with a voice interaction in the final part. As an example, I wanted to use something that maybe can be useful in a town. And I wanted to start with bike sharing. So bike sharing is one of those things that usually people appreciate in towns. They make us live better and reduce traffic. One problem that usually bike sharing companies have is to understand where to deploy the bikes among different stations, because you don't want to run out of bikes in a specific session. So having a way to understand how many bikes will be used at a specific moment in time can be a first step. And I was helped by this website. Anybody here knows Cuddle? So Cuddle is a public website. You can subscribe for free, and they have lots of public data sets that you can use to build machine learning model. And they also run competitions on top of these data sets. So you can participate and see if you find a better solution than the other in creating a machine learning platform. In this case, I used a specific data set that is from the town of Washington in the USA. So this is data that they made publicly available in their open data project. It's data from a few years ago, but the idea was really to show how things work. It's not important that it's the most up-to-date data. And the same approach can be used with different applications. When we start at bike sharing, you can start to understand how bike sharing works. Why I'm saying that? Because usually the first step of building a machine learning model is to understand your data. You can't really use machine learning as a complete black box. You need a little bit to understand how the data, how the model that you are going to build will work. In case of bike sharing, this is a first way to visualize data. For our brains, it's much easier to understand data if you visualize it than if you just see a list of numbers. In this case, I'm drawing the number of bikes that are used in the different days of the week and during the different hours of the day. And you can see that there is a pattern. So there is a lot of bikes that during the week are taken in the early morning and in the late afternoon, and you can imagine that this is for commuting. And then during the weekend, there's a more spread usage of the bikes because people use them probably to just move around the town. But the user of this bike sharing service can have a permanent subscription, so they can be registered users, or they can be casual users that just rent the bike occasionally. So if we split these graphics into these two domains, so on one we see only the casual user, on the other one we see the registered users, we see that the behavior is much more easier to visualize because the casual users, they use the bikes mostly in the weekend, and the registered users, they use the bikes only mostly during the week for commuting. So in this case, you can try to create a single machine learning model for all your users. But it's very clear that there are two different patterns here. So it's probably much easier, quicker, and faster to build two different models and then add them up than to try to create a more generic model. And that's what we are going to do in our demo. Too many computers. So this is the data. So first of all, let's have a look at the data. This is the original data that I got from Cuddle. This is a public data set. Public data sets are really useful in machine learning because since they are always the same. People can play around, test new things, and compare their results with the results that other people had from the same data. So this is the best way to compare different algorithms and different approach. So in this case, I have this CSV file with the date and the time of the day. The season is 1, 2, 3, 4 for the 4 seasons. A flag, a Boolean variable that tells me if this day is a holiday. Of course, a holiday will change the pattern in how bikes are used, so it's important to have it. Another flag will tell me if this is a working day or not. Weather, it's easy to understand that weather is important because under heavy rain you will have less rentals than if it's a sunny day. The temperature, the perceived temperature, the humidity, the speed of the wind. Then for this, with all this information, so I know at the time, all the other variables, I know how many casual users rented a bike, how many registered users rented a bike, and then I have the sum of all the users that rented a bike at that time. And this is all the information from 2011. There's quite a lot of records here. So the first thing that I did was to split the data into registered and casual. And this is also important for another reason. So if let's say that I want to predict the final count, the total number of users, and I give this data to a machine learning platform, the first thing that a machine learning platform will do is to learn that the total count is the sum of the casual and the registered users, and probably the model will just settle saying, okay, I can discard all the other variables, I just can use these 2 variables. So it's really important to not put a machine learning platform in a situation like this where you can just add 2 variables to get the third. So I split the data into registered and casual. So it's the same as before, but here I have only the casual users. And if I go on the registered, I only have the registered users. And then I was still thinking, have I all the data that I need? So usually in machine learning, the different columns that compose your data are called features. And one important step before creating a model is called features engineering. So see if you can create or find other features that can enrich your data before creating the model. So if you look at this data, you have the day as a date, and you have the time, but you don't have the day of the week. So you don't know if January the 1st, 2011 was it was an holiday, that's for sure. But in any case, you don't know if it's a Monday, a Friday. And we notice when we visualize the data that the day of the week has an important impact on the result. So what you can do in this case is to enrich your data. So I created, in this case, I think I used some Python script, something very basic, to add another column that I called day of the week that gives me the name of the day of the week for each of those dates. And usually when you do feature engineering, the best approach is to iterate on the model. So maybe you create the model with the data that you have, then you try to do some engineering, change the features, add more data, and then you build another model, and then you compare with the validation which model behaves better. And this is what I did. So of course, this was a useful information. So now I have the list of registered users and the list of casual users with the day, the time, and the day of the week. And I can use those to create my model. So this is the AWS console. In the analytics section, I have the machine learning platform. And what I'm going to do is to create a new model. And first, I need to create a data source, and then I can create the machine learning model. So I will go quite fast here because since we are replacing someone in this session, but we still will be here at the final session at 5:50. The idea is all the things that we will need to go fast during this demo, during this talk, we can have more time to do a dive deep session at 5:50. So if you are interested and you will not be bored at the end of this session, please come. So here I have the bucket, and what I can do is I will just show the first part. This is the way you can store data on AWS. I have my files. I have, for example, the casual users. I can call this Devox casual bike sharing users. I can verify that I can read the file. And what the platform will do will automatically scan the file. The first line is the column names, so I can use that here. And the platform will try to understand each field what kind of data contains, like the temperature is a numeric field, the date time is a text field for the platform. And you can check if everything works. For example, here you see the season is a numeric field, but I know that there are only 4 seasons. The problem is that I use numbers to represent those seasons, 1, 2, 3, 4. So it's much better to set this as a category than a number, so that the platform knows that this is a closed set of values, it's not some number. Otherwise, it can expect that there's a season 5, like for a TV series. Now I can go on, and the platform will ask, OK, of all this platform, which is the value that you want to predict? And this is the casual user, so I want to predict the casual variable. So this will put this variable as the target of the model, and all the other variable as the input for the prediction of the model. I can now review and continue. There is a step that I was very fast, where you can actually fine-tune the creation of the model. So if you are more expert, you can enter into how data is represented. So I'm saying that for more advanced users. This is the step. So I'm using the default recommended recipe and everything. Otherwise, you can start and customize how data is manipulated by the platform. My recommendation is start with the default and then iterate and try customization to see if they improve the results compared to the first model. And now you can create the machine learning model. The platform will import the data, create the data source, and create the model. This is not very big, so usually this takes something like 10 minutes. But I already created the model. And if we go into machine learning models, we see that we have the creation of the current model, and we have also no, this is the creation, sorry. Here, model. You can see that there are models. This is the model that I'm creating, is pending, and these are the models that are already created. And for this model, I also enabled real-time predictions, so that we can use the application that we will use with a voice interface to interact with those models and create real-time predictions of how the bikes are used. OK, with this, we can go back to the slides. And just as a close-up on this first theoretical part of the presentation, what about deep learning? So in the last years, deep learning is a hot topic in machine learning. And the idea is that, for those that doesn't know, the deep learning is pushing forward an older concept that is neural networks. With neural networks, we create a simulation of how our brain works. We create a simulation of our neurons, and this simulation is, of course, a simplification, is called a perceptron. And then we create a network of layers of perceptrons that behave similarly to our neurons, and then we use this network to give predictions. Each perceptron in this network is actually summing the input of that it receives from outside or from other perceptrons, and it's summing those values with some weights, and the W1, W2, W3, and so on. These weights are the parameters of the neural network, the one that you need to find to optimize the neural network for a specific behavior. And the output of the perceptron is usually something like this. So if all the sum of these values is below some threshold, the output will be 0. If it's above some threshold, it will fire, like our neurons in the brain do. It will fire some output to other perceptrons that are connected with this one. For mathematical reasons, we usually don't use really a squared function, but you use something that you can derivate So it's a little bit easier to use mathematically, but you get almost the same output as the square function. Neural networks were pretty old, but in the past, with the computing power that was available, the experience of the computer scientist was that if there were too many neurons, too many perceptrons, it was really hard to train a neural network, especially if there were a lot of layers. In the end of the 90s, first year of the 2000s, neural networks were not used a lot, but then people started to understand that with the new power that was available, especially with graphical processing units, we have so much computing power that we could train neural networks even if there were a lot of perceptrons, of neurons. And people started also to create different topology, different architectures of neural networks, and those let's say that the use of so much computing power together to create in different architectures gave birth to what we now call deep learning, where we have specific architecture of neural networks that can work for image recognition or voice recognition, and use a lot of neurons that it was not possible to train before. On AWS, if you want to play with deep learning, we have an Amazon machine image. So this is an image of a virtual machine that you can start, and you find the most common deep learning frameworks already pre-installed. So there's Caffe, TensorFlow, Theano, Torch. There's other tools that you can use to analyze and work with data, such as Anaconda. It's a platform built on top of Python. And you can just use this on an EC2 instance, and we have specific EC2 instances with lots of GPU power, so graphical processing using power, like 16 graphical cards from NVIDIA that you can use to speed up your training. To give you an idea of the cost, if you use the smallest P2 instance that is quite powerful, you are in the range of $90 per hour. So you can train easy model with just a few bucks. So lots of talking about machine learning, why it's important, how it works, but what happens if you want to use your application in a more intuitive way, maybe by voice?
Thank you, Danilo. As a developer, I don't know about you, but me as a developer, I'm not a mathematician, I'm not a data scientist, so I'm totally excited to be able to include machine learning and prediction in my application in a very easy way. That's great for us, developer, but how can I expose that to consumer, to end user, to my mom and my dad? They barely can use a smartphone, so how can they interact with machine learning? And what is better than voice? Voice is something we learn since we are baby. Most of the people on this planet, even if they cannot read and write, they can at least talk. So at Amazon, we truly believe the future of human-to-computer interaction is about voice, and we have designed a device for that, and we are selling a device since a bit more than 2 years. It's the Amazon Echo. So what is an Amazon Echo? What can you do with that?
I can play music, answer questions, get the news on weather, create to-do lists, and even read books for you.
So that's the Amazon Echo. You can talk to it. I have 2 Echoes here. I have a big one. This one is not connected. It's just to show it to you. That's the white version. And I have a smaller one, the Dot, which is a bit more difficult maybe for you to see. I'm using this one for the demo because it has a jack output, so you can hear what Alexa will actually answer to that. So let's try to speak to the Echo and see if it works. Because of the speaker of this room, the sound configuration is a bit different than in your living room or your bedroom. So let's see if it works with the speaker. Alexa, good morning. Alexa, good morning.
Good morning. On this day in 1983, Bill Gates introduced the world to Windows 1.0. It was regarded as a flop by critics at the time, partly due to its reliance on this newfangled mouse contraption that people were talking about.
Alexa, where are you?
I'm here and my head is in the cloud.
There is a bit of latency. This is because of the network here and the Wi-Fi. The Wi-Fi is really good, but I can tell you that at home it answers much faster than it does here. So you can ask tons of questions to Alexa, general question, like, Alexa, Alexa, where is Antwerp?
Sorry, I didn't catch that.
Okay.
Please try again.
Let's blame the speaker. You can ask her to control your lights. When I'm coming back home, I can say, Alexa, turn the lights on, or increase the temperature in the living room with Philips Hue, with Nest thermostat. You can play music. Alexa, play Michael Jackson on Spotify.
Playing Michael Jackson from Spotify.
Alexa, stop. Because I want to continue to talk to you. It can also answer very weird questions like, Alexa, how much wood would a woodchuck chuck if a woodchuck would chuck wood?
A woodchuck would chuck all the wood if he could chuck. If a woodchuck could chuck wood.
So that's the type of thing you can do. You can ask her to tell her a joke. My kids are playing rock, paper, scissors every day with Alexa. So how does that work for you, developer? Alexa lives in the cloud. It was one of her answers. So Alexa is running on the AWS cloud, and this is where we are doing the hard things for you. We are doing the speech recognition, and we are doing the natural language understanding. The speech recognition is to transform a voice into text. When I say, Alexa, play Michael Jackson on Spotify, that's the sound of my voice that we transform in words. Play Michael Jackson, blah, 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 blah. The second part of the analysis is to transform that text into an intent, to understand what I mean. When I say play Michael Jackson, play is the verb, Michael Jackson is the artist, and Spotify is the source of my music library. That's the second part of the analysis, the natural language understanding. And all that happens in real time when you're talking to Alexa. On the left side of the screen, you have the device that can talk to Alexa. The Echo, the Dot, but also the Fire TV from Amazon are devices that can integrate with Alexa. The good news is that we have opened the Alexa API. It's called Alexa Voice Service. So any device that you are building yourself, any device with a microphone, a speaker, and a network card can actually tap into the exact same API. So you will find easily on GitHub and YouTube some tutorials to explain you how to create a Raspberry Pi that actually talks to Alexa. As long as the device is registered to your Amazon account, you have the exact same capabilities as the one we have in the Echo or in the Dot. So this is for device manufacturer, hobbyist. On the left side of the screen, we are talking with car manufacturer, home appliance. Imagine all the things you can do in home if you have Alexa integrated inside your electronic device. On the other side of the slide, we have what we call the Alexa Skill Kit. You, as a developer, can add capabilities to Alexa. We have roughly two different types of capabilities to Alexa, the one that are built into the platform, the one that we, Amazon, are building, the one that I just demoed in front of you. But you, as a developer, you can add skills. You can add like application to Alexa. And we have an API for that as well. We have an SDK. And this is what we are going to use for the demo today to create a skill for you that integrates with the machine learning prediction system to call the prediction system that Danilo just talked about. So the flows goes like that. You speak to Alexa. Alexa listens to you. As soon as the blue light is on, it means that it streams your voice to the cloud. It records your sound and sends that to the cloud. And in the cloud, we are doing the hard stuff for you. By the way, we are also using machine learning inside Alexa to train the voice recognition model. Alexa is continuously learning. We train her with real production data. So from 1 week to the other, or from 1 month to the other, you can get new capabilities or higher accuracy in terms of speech recognition. Once we detect that the intent is actually for your skill, we will send you a message. We will send you a JSON document to your code, and then it's up to your code to actually do something with that. So when you implement a skill, you need to write code That's the things you and I are doing for a living. We are in the right place to talk about that. And all what you need to do is to receive a JSON document that we are going to send you. So the output of the Alexa Cloud is a JSON document that specifies the intent, what the user wants to do, and maybe some parameter. If I'm asking Alexa to order a margarita pizza, order a pizza is the intent, and the margarita is the type of pizza. It's a parameter. It's like a variable inside the voice model. So you will receive that JSON code, that JSON document. You do something called backend API on your side, called third-party API, and you give us another JSON document as the answer. The JSON document will contain the text-to-speech, so the text that Alexa must answer. We will generate the voice of Alexa in the cloud and stream the sound back to the device. So the devices are really, really simple. There is minimal software on the device, just microphone, speaker, network interface. Everything happens in the cloud. So you have to write code. You have to write code. So where are you going to host that code? Actually, you can host it anywhere, as long as you can speak HTTPS, receive a JSON document, and send back a JSON document. That's good for us. I have some demo that runs from my laptop, but if you are going to go into production, you need to host your code somewhere else than on your laptop. It might be on premises inside your data center. But we are at Amazon and we love AWS, so one very good candidate to host your code is on EC2 instance. It's virtual machines, Linux, Windows. But then you have to set up this virtual machine, you have to patch Linux, patch Windows, install runtime libraries and things like that. And you have to be sure that your code is highly available, because you might have hundreds of customers using Alexa and talking to your skill at the same time. So you must be available to ensure that you will answer whenever you receive a request from Alexa. And you must be able to scale, maybe from 1 or 2 instances to many instances. So if you want to be a bit more professional in terms of deployment, you will end up with something like that, with load balancer, web tier, internal load balancer, application tier. You might have a database as well to keep track of profiles, so that database needs to be highly available and things like that. And of course, you don't want to manage such an infrastructure just to deploy a skill for Alexa. We have some tools at AWS that can help you to do that. Elastic Beanstalk is one of them. It will generate that, but at the end, it's still the same infrastructure. It's load balancer, auto-scaling to scale your virtual machines, internal load balancer, and other very low-level infrastructure that will not make your skill better. This is just plumbing. This is low-level infrastructure. So we have another service that can help you to deploy your code. It's called AWS Lambda. Lambda, it's a container, it's a runtime environment for your code. As a developer, as I will show you during the demo, you just upload your code to Lambda, and we, Amazon, take care of all the rest. It means that you don't have to install a virtual machine, to install an operating system, to install and to maintain a runtime environment. We do that for you. Whenever something invokes your code, like Alexa, for example, invoke your code will be run inside Lambda. And you don't have to care about scaling, about high availability, because we will do that for you. Another good news about Lambda, it's the price of Lambda. It's $20 20 cents per millions of invocation. And the first million of invocation is free for you every month. So as a developer, it's very unlikely that you generate more than 1 million invocation per month. So as a developer, Lambda, it's basically a free service for you. So developing your code is one side of developing a skill, and hosting that code somewhere is the first part. The second part is to directly interact with the Alexa skill kit. And you have to tell us what will be the voice model, what will be the intent, what will be the function that your skill will perform. If I'm creating a skill to order food, I will have probably an order intent, a get status intent, maybe a pay intent. And you have to tell us this intent. An intent roughly matched to a function. You're a developer, so you know what is a function. An intent, it's a voice function. So you have to define these, and we have a very small JSON document that you need to give us that defines the list of intent that your skill will support. An intent might be backed up by many different utterances. So an utterance is the phrase that your customer might pronounce to interact with your skill. For a hello world intent, my sample utterance will be hello, say hi, say hello. To order food, my sample utterance might be, order me a pizza. Please order a pizza. Order a pizza, please. So the more sample utterance you provide, the better the accuracy of the voice model, of the voice recognition will be. So we encourage you to generate a lot of sample utterance. These are basically all the different ways that your customer will be able to interact with your skill. And you need to give that. It's very common to have several hundred, several thousand sample utterance in that file. Once again, the more you provide us, the better the speech recognition will be. And then you might have noticed that I have something like first name in this hello world. First name, it's what we call a slot. A slot is a parameter to your function. If I'm writing a skill to order pizza, the type of the pizza, margarita, other type of pizza, maybe you can... Thank you. That's the parameter. So it's the same intent, but you have multiple values that can be passed as a parameter. Once again, your developer, you know exactly what a parameter to a function is. A slot is exactly that. So you can create your own type of parameter, your list of values that you support, but we also provide you a couple of predefined slots for dates, for number, for cities, countries, US states, and things like that. And with dates, for example, you can expect Alexa to do some fancy things for you. So as a date parameter, the customer can say tomorrow or in 1 week, and we will transform that into the cloud and give to your code in the JSON document the actual date and not what the customer say to Alexa. And the last part is the code. This is just a sample with TypeScript in JavaScript. I have two intent here, help and hello world. I extend a bit TypeScript to add annotation to correctly route intent to a function. But you can write code with anything. As long as you are able to receive a JSON document and to send back a JSON document, it might be Node.js, Python, Java, of course, anything, we don't have a specific preference. So in the session later this afternoon at 6, we are going to create a skill together. You will see the detailed process of that. I will quickly browse into the console for the time left. Once your skill is ready, you can publish your skill. We will verify it to ensure that there is no illegal stuff, and it follows a couple of policies that we have in terms of publishing skills. And the skills will be available on the skill store, where customer can select for them, can comment, can provide feedback, can enable them for their specific account. So let's see how it works with machine learning. On the right side of the architecture slide, we have the machine learning prediction system that Danilo just built. Remember that Danilo enables real-time prediction. So that we have an API that I can call on his model to get a prediction about the number of bytes that will be used. And you saw maybe when we feed the model with data that the number of bytes used depends on the weather. Of course, if it is good, if we have a good weather or bad weather, the byte usage will be quite different. So we, Danilo and myself, create a skill that will be invoked by Alexa. And when I say, get me the prediction or how many bytes will be used for that specific time slot, the skill will call a weather API to get the weather prediction for that moment in time. And once I have the weather data, I will create a request and send that to the machine learning service, to the prediction service. Then the prediction service will use the model, will do whatever it wants to do, but will retrieve me the value that actually I'm waiting for, which is the number of user, the number of bytes that will be used. And all that happens in real time. 200, 300 milliseconds, including the call to the weather forecast API. Alexa, open bike sharing.
Welcome to bike sharing prediction. You can ask me how many bikes will be used on a date. How can I help you?
How many bikes will be used tomorrow afternoon?
It will be a Friday and a holiday. It's Veterans Day. The weather will be clear, so I expect that 242 bikes will be used, 22 from casual users and 220 from registered users.
So in theory, we can also do one-shot invocation, like give the name of the skill and the intent. Alexa, ask bike sharing what will happen tonight at 8 p.m.
It will be a Thursday. The weather will be clear, so I expect that 171 bikes will be used, 48 from casual users and 123 from registered users.
So how does that work behind the scene? I have a Lambda function that we created. This one is in Python. And okay, there is a lot of low-level things to manage the holidays and the season and things like that. But the interesting part is this one. Can I zoom? Yes. I first call the weather API to get some weather forecast, and then I'll just prepare an object with the day of the week, the fact, is it a holiday or not a holiday, what day of the week is it, what will be the weather, the minimum temperature, the humidity, the wind level. These are all the parameters that the machine learning system expects to make the prediction. And after that, calling the machine learning system is as easy as this. I'm calling the machine learning system first for registered user, giving the prediction params as input, and I receive the prediction, which is just a number for registered user. And then I make a second API call for the casual user, and I receive the number. All the magic, all the complex mathematical stuff happens at the time where you build the model, and happens within the Amazon machine learning system when we receive this parameter, and we have to find the answer or the prediction for that question. And the rest is just assembling these results, creating the voice output. Once again, at 6 p.m. this afternoon, we are going to dive deeper into that and show you end-to-end how to create a skill. When you create a Lambda function like that, of course, you don't want that Lambda function to be callable by anyone on this planet, so you can have a couple of triggers, and the trigger here is Alexa skill, so only Alexa service, the Amazon Alexa service, can trigger that Lambda function. And you have basic monitoring information available directly from the Lambda console, so the number of invocation, the duration of this invocation, and you have direct access to the CloudWatch log, where you can see all the data that were generated by the logging of the Lambda function at runtime. You can see that as a plain text. I'm logging a lot because it's a demo, it's debugging stuff, so I'm logging the request that we receive. That's an example of a request sent by the Alexa service to my skill, and you see that the date has been transformed as a date, the time, when I say tonight at 8 p.m., and a bit later, we should see the result, registered rental, casual rentals, and the answer that is generated by the skill with the text to speech. So this is the text that my skill is giving back to the Alexa voice service in the cloud, and based on that, we will generate the text to speech and give the voice that you heard from Alexa. That's the Lambda part, and the voice model part, it's pretty easy as well. I need to switch console. It's the Amazon Developer Console now. Going to the Alexa skill kit. You see all my skills, and this one is for DevOps. The first part, the first screen, you define the language. Today we do support 3 different languages. We do support traditional English, UK, simplified English, US, and we also support German. And of course, supporting many different customers in different languages is very important for us. So I know that's one of the questions I will receive after this talk. When are you going to add French, Dutch, Spanish, Italian? We are working on that. We know it's important. We have full resource working on adding multiple language to Alexa. You need to build your interaction model as well. So the list of intent, we have a bike sharing prediction intent that receives 2 different slots, a day and a time. We have a help intent, a stop intent. A help intent is actually mandatory. If you want to publish your skill on the skill store, you must provide a help intent. So you must, as a customer, I should be able to say, ask bike sharing for help, and to receive a meaningful answer from that. The sample utterance, we don't have too much here. We have just 52. Once again, it's a demo. In real life, you will have probably hundreds of different ways to invoke that bike sharing prediction intent. We have very small ones, so we can say Alexa has bike sharing prediction for tomorrow afternoon, and that would be that sample utterance which map to that intent. It's the best practice to also include things that are not grammatically correct, because you don't know how your customer will actually speak to Alexa. And the two last parts, the configuration part. In configuration, you just give the endpoint of your Amazon Lambda function. So internally at Amazon, we have Amazon resource name. These are this fancy number here. That's the reference to my Lambda function. You can host that in North America or in Europe. You can also use an HTTPS endpoint. So if you want to host on the Google Cloud, on Microsoft Azure Cloud, on premises inside your data center, we're totally fine with that. Lambda is just there as a convenience, a very cost-effective convenience. And you can test that directly from the Alexa console. So for example, you can ask for predictions tomorrow afternoon. Oops, small typo. So you simulate what the user would say. This is the request that we are going to send to your skill. So it's very handy to copy-paste that and to do some scripting if you want to automate your test, for example.
Yeah, exactly. For test cases.
For testing, exactly. Often. And this is the service response. So this is what we receive, This is what we receive back from your skill. So you can see if the Alexa voice service did receive something from your skill. Most of the time, the first time you receive, or you are testing that, you will see an error message there saying, hey, I cannot talk to your skill, or the response is invalid. Then you have to go back to the Lambda function and to understand why the response was invalid. And you can play that as well. Anyway. So you have
It will be a Friday and a holiday. It's Veterans Day. The weather will be clear.
You get
so
it.
I expect that
so you can hear the response that actually Alexa will send to the device. If you don't have a real device, because these ones are currently available only on UK, US, and Germany, there is also a tool called ecosim.io that you can connect to. You need to authenticate with your Amazon account, and then you can speak to your browser. So the speaker and the microphone depends on the quality you have on your laptop. It's not the same as on the real device, but if you don't have a device, it's a quite handy tool to test your user interaction. Only available on the US language for now. We'll add support for UK and German very soon, probably first quarter next year. That's pretty much it. I talked about CloudWatch, about the skills, so we can go back to this one. And that's the demo we wanted to show you using machine learning, prediction, some super advanced stuff that I don't understand. I read stochastic somewhere on one of the Danilo slides. I still have gray hair from my time at university because of stochastic. I don't want to understand all that. I'm just a skill developer, and I integrate with that with just a couple of lines of code to create a voice experience on top of Amazon machine learning.
Yeah. So I hope it was interesting. If you want to dive deeper into the components that we used to build this demo, we will have the session at 5:50. And the only suggestion is if you want to build an application, focus on the unique idea that you have. So use the providers as services. Don't think of servers, and just focus on what you want to build. Thank you. If you want, sorry, I forgot. If you want to start, these are the two links that we use. So developers.amazon.com is the Amazon portal for creating the skill, and AWSamazon.com/free is the free tier. As we said, for Lambda, you can start using everything for free. Thank you.